Welcome to this Wood Solutions presentation on timber's insulation properties and its specific heat capacity. All buildings have to comply with regulated thermal performance requirements. So timber's thermal performance, how heat flows through it or is stored in the wood, influences how it is used and performs in buildings and other applications. Timber's organic and cellular structure means that wood has significantly different thermal performance characteristics to other major building materials such as steel, concrete and masonry. Before we look at timber's thermal performance, it is important to establish some key definitions. The first is thermal conductivity. Thermal conductivity is the rate that heat will conduct through 1 meter of a material. This is known as the material's U value. If heat flows through a material quickly, you will have a high U value. If it flows through a material slowly, it will have a low U value. A material's insulation value, or resistance to heat flow, is the inverse of its U value adjusted for the material thickness. This is known as the material's R value. The formula for this is a material's R value is equal to 1 divided by its U value times the material thickness in meters. R values are regularly used when insulated products are discussed. For example, insulation may be an R2.5 or R4 product, and we know R4 is a higher level of insulation. Hardwood and softwood have useful insulation properties, especially when compared to other major building materials. They have a higher R value. This chart shows the thickness of material needed to achieve the same level of insulation or R value as a 100 mm thick softwood panel. To achieve the same level of insulation as a 100 mm thick softwood panel, you would need a concrete wall 1.2 meters thick. Similarly, you would need a 3.3 meter thick glass wall, a 38 meter thick steel wall, or a 208 meter thick aluminium wall. Timber's high insulation properties help reduce thermal bridges in buildings. Specific heat capacity is the amount of energy needed to raise the temperature of a unit mass of the material by 1 degree. In thermal performance design, the specific heat capacity is directly related to the building's thermal mass, the amount of heat that it can store. Hardwoods and softwoods have useful thermal capacity. This chart shows that a 100 mm thick hardwood panel has similar thermal capacity to similar concrete, glass or aluminium panels. At the same time, it is much lighter. One point to remember, however, is that timber is a better insulator than other materials and so has slower response time to temperature changes than other materials. In summary, timber's organic and cellular structure means that wood has significantly different and useful thermal performance characteristics when compared to other major building materials such as steel, concrete and masonry. Timber is a more efficient insulator than many other structural materials. This helps to reduce thermal bridges, and it has a useful thermal capacity and can contribute to a building's thermal mass.